Welcome everyone. So this is Our Ladies Room. So we are very happy to have you all here. So as you've seen, we are 75 people already. Hello, Cédric. How you doing?
I'm fine. All good. How are you? Good to see you all. Welcome.
Absolutely great. So very excited to this talk, as you know that I love data visualization, and so what better than have you here with us? Great. So let's get started. I start introducing our chapter, and then I leave the floor to Cédric without spending any much time. Okay, let's share my screen. Can you all see my screen? Yeah. Okay, so welcome to Our Ladies Room, even more exciting data visualization with ggplot2 extension. Speaker Cédric Scherer. I pronounced it right. Okay. So before all, so I'd like to remind you that this talk is recorded and will be posted on YouTube. You can watch it again on youtube.com at Our Ladies Rome. And please remember that all our attendees are expected to adhere to our code of conduct. You can have a look at the COC, code of conduct. And we do this because we like to create a safe environment, an inclusive space, free from any form of harassment, fostering a respectful environment for everyone to learn and connect. But feel free to use the chat, raise your hand for asking questions, most probably at the end of the presentation. The material for today, so this is going to be a watch and learn session. All material will be shared during the presentation, then you can have a look and look at all the code that will be shared. But in case you'd like to do and learn, you need our studio. And so you might want to download your studio if you don't have already on your computer, or you might want to use POSIT Cloud, which allows you to use our studio without any installation. So again, welcome everyone. This is the first data visualization event of November. This month is also special significance for exploratory data analysis, and we are fortunate to host one of two fabulous events featuring expert data visualization professionals. Cédric Scherer, our speaker for this session, and Cara Thompson. She will join us on November the 3rd. So we are honored to welcome Cédric, a mentor, a tremendous inspiration. Cédric is a field expert and founder of the 30-Day Chart Challenge, providing an excellent opportunity for practice and networking within the data visualization community. As you can already see, all is amazing production. So I'll be sharing a bit more about our chapter and activities before handing over the floor to our speaker. Who are we? So my name is Federica Gazzelloni, and I am the lead organizer for Our Ladies Rome events. We organize talks, workshops, tutorials, generally sponsored by the R Consortium and the Linux Foundation, all with the mission of promoting the R language within the data science community. We are a diversity-friendly community, And personally, as a statistician and actuary, I'm passionate about data visualization. So I actively participate in competitions such as Tidy Tuesday, 30-day chart challenge, and the ongoing 30-day map challenge, which is a challenge. So the other organizers are Katie Wood and Francesca Piccone. They are both experienced marketing manager and statistician actually, so professional in the field of risk management. What is Our Ladies in general? Our Ladies is a global organization with the mission of promoting the art language for the empowering women at all user levels by building a collaborative global network. It is a gender diversity blended community, which was founded in 2012 by Gabriela De Queiroz in San Francisco. And it is now a worldwide organization with 219 chapters because they are founding new chapter every day in about 63 countries and 3,943 events and more than 93,000 members globally. So it's a growing community. You can visit ourladies.org to have a look at the website, have more information. So Our Ladies Rome, it's part of Our Ladies Global, and as well as dedicated to promote gender diversity. We do monthly meetings, almost every month, sometimes even twice a month, and provide a platform to discuss current trends and hot topics in art. But not only that, so we do talks about careers and many things. So we encourage active participation and engagement for all attendees. So we welcome suggestions, comments, and invite you to get in touch and join our vibrant community. You can get in touch here, sending an email or through all the many social networks that we got. So you can write us at rome@ourladies.org. What we did so far, this is the first year of Our Ladies Rome, has been very intense with a diverse array of events. We had talks and on workshops, coding sessions, engaging panel discussions. So the gathering have all shared a common theme, our passion for art programming language, data science, and statistics. So we also had machine learning, infectious disease modeling, and so we expect much more next year. Our next event, as I mentioned at the very beginning of this presentation, will be on the 30th of November with Cara Thompson, continuing with the Data Visualization Month. She will lead us through 10 tips for better text, typography, math, ggplot, and friends. So in December. And we will be partnering with Our Ladies Paris for the following month, but more information coming soon. Finally, your support and involvement are crucial to our success. So you can support Our Ladies Rome on opencollective.com/ourladiesrome. We are an open collective, open source community supported by the Art Consortium and our members. Finally, today's presentation, Dr. Cédric Scherer. So he is a data visualization designer, consultant, and educator with a background in ecology. He blends analytical expertise with design passion, applying skills to diverse disciplines. Known for his Study Tuesday contributions, Cédric's mission revolves around merging data analysis and design principles to deliver effective and visually appealing visualizations. So without further ado, I'm thrilled to hand over the virtual stage to Cédric Scherer. His expertise and insight promise to make this data visualization event an exciting experience for all. Let's dive in.
Thank you very much, Federica, for a nice introduction and great to be here. I'm also going to share the right window here, if I can. Here we go. So yeah, it seems to be a good week for our ladies and DataVis. Whoever hasn't checked out Tanya's talk, who's already also here today, was a great session. So I'm going to continue going back to ggplot2, but I also will have some interactive and CSS stuff here. So yeah, I'm excited to give this talk again. I was giving this a few weeks ago here in Berlin in person. So I'm excited to now have a platform to kind of like also make it available for people all over the world. As we have seen from the chat, wonderful, really like I saw a lot of different countries in there. I'm very happy to welcome you. I don't need to kind of say much more about me. Federica said a lot of welcoming words here. So I'm a freelance database person, expert, specialist, designer, instructor, whatever. I'm mostly doing consulting, so working together with clients, working on data workflows and data visualization, still mostly with R and ggplot, doing a lot of coaching on general principles of data visualization and working with ggplot and all of this, yes, with RStudio and all these nice packages we see here on the laptop. So some of my previous works here collected, these are some works for clients, working with Scientific American, the USGS, the German Institute for Population Research, and some others. And Federica also mentioned several challenges here, and I feel kind of bad because I'm not that active anymore currently because of other duties, private and personal stuff. But here's some of my contributions. So this is basically how it started. So I was studying and doing my PhD in ecology and finding out about ggplot2 and fell in love. And after my thesis, I went into all of the challenges, first of all, Tidy Tuesday, but then also the 30-day challenges and so on. And if I'm allowed to kind of like work on these personal projects, I'm often coming up with more colorful, more uncommon charts. So short plug here for my webpage. It's a blogs type webpage where I unregularly share some insights on DataVis and ggplot codes. I just want to highlight two things here. One is the ggplot tutorial most of you likely know already. It features now around like, I don't know, 200 examples of how to adjust and modify ggplots. And still one of the highlights from last year, I was honored to give a workshop at the RStudio Conf in Washington, DC, which is all available for free. Open access available. So it's a 2-day workshop of basic and advanced stuff. You will find like the slides, codes, exercises, and so on. Also the workshop from this year from PositConf, they are online, but I haven't shared them yet publicly or widely. They're already available. And lots of codes can be found on my GitHub as well, mostly for my personal projects and the challenges. So if you feel like we want to have a look how these charts are created, feel free to check out my GitHub. So Federica was so nice to already share the contents for today. So there are the slides. If I can find my chat, I will resend it again. The slides are available as well as a script. If you want to follow along, I suggest to do this afterwards because I'm going to these examples rather quickly to give you more an insight on the packages and not really like the details of the code. So you can explore them later with the script. And I'm using a custom typeface as always, so you will find the font files on Google Fonts. Okay, short introduction on ggplot. I think all of you know this wonderful library. This is just the description text of the package itself, which is very technical, saying that it's a system for declaratively creating graphics based on the grammar of graphics. So it's about the layers we can combine to create all kinds of exciting visualizations and maybe also unusual ones. And this is what I'm mostly going to talk about new layers which are provided by other packages, which are part of the ggplot universe. A general ggplot or basic one always needs 3 things. It's the data, so the data set we want to visualize, initialize with the ggplot call, then a mapping of our variables to certain aesthetics, and then a geometrical or layer or a statistical layer to create the geometry. In an advanced or more polished plot, if you want to fine-tune this and modify it, you might want to use statistical transformations, facets to create small multiples, play around with coordinate system settings, use scales to adjust the aesthetic mappings, and maybe also modify the theming. So I'm still using these wonderful drawings by Alice and Horst. Kudos to that again, because they are kind of featured in all of my sessions. So Alice and Horst here nicely showed that ggplot is a great tool for visual data exploration, and these flying charts may look familiar to you. These are more basic charts. We see the default color palettes here, and these are just some examples from the ggplot webpage. So these should kind of look familiar to you. But as Alison also kind of created this one where it's about building a data masterpiece with ggplot2. And you already can see like certain boxes here in certain charts that there are custom colors, maybe unusual geoms which are not coming with ggplot itself, maybe even animated or interactive charts and so on. So here I have a collection. There are tons of great examples, especially thanks to Tidy Tuesday and all the contributors. So here's some variety of charts, maps, different graphics, even generative art and some pixel art by several people, including Thomas Lynn Patterson, Georgios Karmanis, Tanya Shapiro, Jake Kaup, Jake Davison, and some of mine. And these are created often with the help of some extension packages. So what is an extension package? ggplot2 provides a lot of layers and additional functionality, but there are several packages where people thought like, well, this would be cool to have this certain chart type or this functionality to be added to ggplot. So this is basically the whole world of ggplot extensions. There is, and it's linked here, the gallery of ggplot extensions hosted by the Tidyverse people. These are 128 currently registered extension packages, nicely sorted here by likes or whatever you decide on. And there are even more. This is a curated list where people can contribute to. So that means not all of the extension packages are listed here. Another great resource to learn about material on ggplot2 and extension packages is the awesome ggplot2 GitHub page. Here I'm just a short recording or longer recording on how long this list is of extension packages, and then it even continues with blog posts, workshops, materials, and so on. So feel free to also explore that one. I had to focus on a few packages, so let's jump into it. And if you want to keep up to date or want to be up to date with the latest developments, I still recommend Tidy Tuesday, because those people contributing to this challenge are often exploring new options and using this opportunity to play around with new packages. So we are going to work with a data set which I'm now using for quite a while, I think since last summer 2022. It's a bike sharing counts data, which is offered by the Transport for London Open Data API. It covers 2 years, 2015 and 2016. I'm not going too much into detail, but that's the data sets we are going to use. Before we can obviously plot the data, we need to import it. So here I'm saving it in an object called bikes, which is then a data frame. I directly link the data from an URL. So this is hosted on my webpage, so you can also source it from there. And then with the call types argument of the read_CSV function, I can specify the column data types. So I make sure that factors are factors and so on. This is a short overview of the data. So if you want to play around with the data a bit more, you feel free to consolidate that list. We are working also with 2 data subsets here, quickly jumping into it and a bit of data wrangling. The first one is a simple one. First, I load a dplyr package to wrangle the data. The first one will be just daily bike shares. There's a day and a night period. So I save that in the bikes _day object. And then there's some monthly data where I use the lubridate package to create nice, meaningful labels for my months. And then I summarize the values per month for the year 2016. And then more setup steps now related to our data visualization. I call the ggplot2 package to have the general functionality available. And then what I always suggest to do, and usually you will find in all my scripts at the very top, is to kind of like update the default theme. So with the theme set function, you can set a new theme, and I'm using the minimal theme here. with the ASAP semi-condensed family and a bit bigger labels so you can read them properly. Afterwards, I modified 3 tiny things with the theme update function. So this then applies to all the plots that are created with ggplot afterwards. So the plot title will be aligned with the plot margin, the left plot margin. I increase the plot title a bit further, and I remove the minor grid, which, yeah, don't get me random about it, but I don't like it, so I always remove it. Okay, I try to kind of put these packages together in certain sections. So the first section would focus on visualizing distributions across categories. So if we would use ggplot alone for that, you maybe would come up with a box plot here. So we initialize the plot with ggplot, then the data, and then we map the 2 variables, this categorical variable season to the x-axis and humidity, which is continuous, to the y-axis. And we can then add one of the layers which are suitable for this kind of data. So this is, for example, gm_boxplot. This is a very specific chart type, and there's nothing bad about box plots, but there's certain ways or other ways how we can visualize that, or maybe even combine that. Some people like violin plots, so these are also provided. They're not very well designed here. It's a simple violin plot. You still need to do the filling and stuff, but it's available with the GM violin already and ggplot2. And some people also like to combine those to have both like the summary statistics of a box and whiskers plot and the general distribution with these kind of violin plots. The first and likely one, well, maybe the package I am interested in the most, or like the most use for me, is the ggdist package. I think it's wonderful. It was originally developed to visualize distribution from Bayesian analysis, but we can also use it for all kind of raw data and showing distribution of categories. So similar to the GM violin, there is a stat_i function inside the ggdist package. So this connotation, if you don't know about that, the colon is called a namespace. So I don't have to load the package, and for you, it's obvious where this function is coming from. So ggdist is an extension packages which provides so-called statistical layers. They are starting with stat_, and then the new one here coming from that package is the I-plot. The I-plot is a violin plot with some additional metrics or summaries inside. This is not a box plot. This is showing now the mean, the 66% range of the data, and the 95, if I'm correct. If you don't like to have these mirrored density curves, you can also use the half-I function. And here we see the default width is 66 and 95, so 66% and 95% for the thick line and the thin line. So this is not replacing a box plot, and we had in the last meeting, we had a lot of discussion around if this is meaningful or not. As always with error bars and all kind of these things, you need to be very explicit about what they are showing. And you can also adjust these because, well, this is code, right? We have a default, but we can overwrite the default. So if we want to overwrite the width, for example, to make something similar to a box plot without the whiskers and the outlier, but the box itself to show the 50% inner population, we could go for a single width value of 0.5. Or here on the other side, I show you how you could just indicate the full range of the data, because sometimes these density curves become very thin. So this is a way how you can maybe highlight the full range. By setting 0 and 1, I'm using the small line of these error bars, and the thick line is just gone. You can further customize these geoms. Matthew Case, who has developed the ggdist package, put a lot of additional arguments in there. So for example, here there's the adjust argument, which allows you to modify the bandwidth. So you see it's now more curvy, the fitting of the data distribution. We can change the shape and the size of the mean point, but also like, of course, the filling and the colors and so on. So this is what I have used for the penguins visualization I did back then for Tidy Tuesday. In the lower part, you see this kind of like variant of a rain cloud plot where we have a box plot, a stylized box plot. Is I was trying to imitate the Tableau box plots, which are look kind of like modern and fancy. And then a barcode plot showing the raw data, and then the GG half-I, the stat half-I from the ggdist package, which is used to indicate the mean value, the distribution, and the full range. I also have used it for this piece here, where I compare the speech weights and the information weights of certain families of languages here. And you see there's also like now grouped. So we kind of map the color and filling to the different rates in that case. And then you see the mean points are also connected with the line. So this is an additional geom, but the overall plot was created with ggdist as well. So how would you create or at least get started to do this? This is pretty simple and straightforward. As mentioned, you need another aesthetic here. We map the day, night in our bikes data set to the fill variable. And then by default, we get 2 distributions for each of the seasons here. And we also get 2 points. And to have not overlapping error bars here, I just set the width to 0, which means we move all of them. And the rest is just styling. Here I'm using the shape 21, which is a circle with an inner fill and an outline color. So I don't have to also map day and night to color. And I can reuse the fill from the area also for the points. And then in the final step, I'm just defining, because I don't like the default colors, I'm defining my manual colors here and remove the title from the legend. If you have questions on particular topics here, or Federica, if you see some urgent questions, then feel free to also raise them now. I'm not looking at the chat, so I might continue talking, but we also will have definitely time afterwards to discuss it.
Yeah, because we said that maybe the questions that were good at the end of the presentation, but
yes.
In case you have any question, please put in the chat. So we raise the question to Cédric.
Perfect. Okay. So lots of flexibility, and the usual behavior of the layers is still contained. So also as a side note here, I'm just packages I like myself. I'm not really a fan of wrapper packages, and there are lots of cool utility packages, but here, as mentioned, I focus on basically true ggplot extension packages where we kind of like add components to our plot. Another interesting one, which I'm using quite often, is the multi-interval bars or lines that are also part of the ggdist package. This is the default. The default shows 3 levels of the population. So the 50%, 80%, and 95%. A note here, as a database expert, I have to note that the default colors is rather suboptimal, because we want to have the darkest color on a white background for the most important information, which is likely the inner group, not the outer ones. If the story is to focus on the outliers or the more extremes, then this choice is very well. Here we can customize it. So again, there's a .width argument in the stat interval function as well, where I'm using this formula. So 1 colon 4 creates 4 different numbers. And then I multiply it by 0.25, which results in these 4 different levels of 25%, 5%, 50%, 75%, and 100%. And the line width, so this is a way to kind of like make this a bit bolder, otherwise it may look a bit lost here. And then I'm using the inbuilt ggplot2 function scale color viridis with a D here, because we have 4 categories, 4 levels, with one of the custom viridis color sets. And you can combine that. Here I combine 2 ggdist layers. I use still the stat interval to indicate the range, and I see that the points are overlapping here. This was not the case in an old version. That's definitely something you can fix. That was not intentional. And then I use the stat underscore dots function from the ggdist package, and with the adjusted position, with the position nudge, I move it a bit to the right, so it's not overlapping with the interval here. And this gives you an insight on the number of observations. A side note here, we have more observations than points on this chart. So this is also aggregating, so it's scaling it. The general recommendation likely would be to use it for single observations, because if 1 point represents 5 or 10 or 50 observations, then a histogram might be more suitable here. This is exactly what I have used for Not My Cup of Coffee visualization. I've created to visualize ranges of and individual ratings of coffee beans and by country here. You could also obviously go back to the half iron, combine it with the stat interval, not going into detail here. The logic follows the same as before. We remove the width and we adjust the position on the x-axis. And this is what I have used in a quite old visualization, challenged contribution from 2019 to the storytelling with data. challenge on the topic of visualizing uncertainty, where this is showing the range of temperatures in Berlin measured across 18 years.
I have a couple of
Yes.
questions in the, oops.
Sure, let's answer them.
Okay. Isn't this Viridis team that was Viridis
exactly,
and discrete? Oh, okay, for discrete values.
Mm-hmm.
Then we have. I was also wondering from which palette the colors are taken. They are very nice, and so that the color, yeah.
So the Viridis, this one. So this one is one of the featured color sets in the Viridis package. So if you look at the Viridis package, you will see that there's a range of those. We know the default Viridis, the green, yellow, purple one, but also like red ones, Plasma, Inferno, Rocket, and then the Mako one has this range of black to blue, green colors here. The other two colors I've used for the groupings. Where was it? These are just some of my favorite colors I've picked by hand.
And then there is another great question. How would you combine multiple charts together as they don't look like stacking them next to each other or on top of each other like you would do using patchwork?
Yeah, that's patchwork. I'm not going to cover it today. It's in the appendix slides. So if you look at the slides, you will find also some slides on how to use patchwork to combine graphics. Exactly. Perfect. So this was on the penguins, for example. They have used patchwork to have two charts, the upper one and the lower one, and then also have separated subtitles for each and so on. Yeah. Okay. ggDis has quite some other functionalities. I'm not going to cover all of it because we also want to see some of the others, but these like radial ribbons here, you can also highlight specific parts of your half eyes or whatever GM. This is the usual behavior. And you can also see like some cumulative densities and so on. Feel free to explore the page. There's lots of documentation on these. So next one, very similar use case is the ggriches package. And someone last time asked if this is actually now something we don't need anymore because we could use the ggdis package to create the same. And that's at least for the basic rich line plot. It's definitely also an approach you could use using the ggdis package to create something similar. So what's a rich line plot? It's these density curves that are overlapping, so with a bit of spacing to avoid that kind of like all of this becomes a mess with lots of colors. Some people love them, some people hate them. Not going into what's great about them, what's not so great about them, but the ggriches package offers a way to do that. Now I flipped the categorical and continuous variables here to have the seasons on the y-axis. And then we can use the gm_density_riches function from the ggriches package. And as before, you could also group that and customize it. So here I'm again using the day and night variable to kind of like split these seasonal distribution curves into two. And then I add a bit of transparency to indicate the overlap of these distributions. So this is not, it's a quite a okay plot. You can further streamline this. So here I'm using the color argument to draw a white line, which looks a bit cleaner because it's basically invisible where there's no data. You could even remove the extended tails of it. And I'm using the scale argument to control the overlap. So you see that these densities now between seasons are less overlapping. So you can also further customize these things. And then again, I'm using the manual fill colors. So to bring an example here, it has been used for the Catalan elections, but also for the American elections to showcase how much different parties are similar or differ in their votes here. And usually this is kind of like an American example as well. And this should be the same here, like how polarized these parties became, moving more and more to one of the side of the spectrum. So this is one of the use cases for this. There's lots of other functionality. For example, in other GMs, there's a GM density, which is gradient, which allows you to also map a color to the x-axis. It's not giving you an additional information in that sense. Could be a visual cue if you have one which is all purple in that case and one which is all orange, but obviously also the position on the x-axis already indicates that. But you could also add a median indicator line, or you could color the tails based on some statistical percentage of the distribution and so on. And here I'm now using a custom gradient to create this color. The next section would be visualizing X and Y relationships. So usually scatter plots. There are common problems with scatter plots. If you have a bit of more data, but already here, you end up with lots of overplotting often with scatter plots, especially if you have like a huge data set. And then you run into the problem that you can either have a transparency, which works well to make all the points visible, but you still have a black buff, like all of them in one place, and you can't really see the density of points, or you end up with very light points, and then you hardly can see individual ones. So there are some approaches to handle this. One of the packages I want to showcase here is the ggplot density package. The ggplot density package works with the idea that we color the points based on the number of neighbors, which means the more points are in a given area, the darker the color. By the way, I didn't mention it, the packages are also linked here in the footer. So if you directly want to jump to the documentation, you can use these links. So the same scatter plot now with the ggplot density package and its gm_point density layer. And here you see by default, okay, I set the darker color. Now by default, it's the lighter color. Again, if we want to focus on those points which have lots of neighbors, then we want to flip these color palette. And you see that the neighbors ranges somehow between 1 and 30 maybe, or 25. And the color indicates this. It's still drawing individual points. So this is basically a compromise of a true scatter plot and some binning. So you could also create a tile binning or a hex binning here to count the points. But here we still have the raw data in kind of X and Y position, but an additional indicator how many points there are. You can adjust the area, what's meant to be a neighbor. There's a bit of guessing or fine tuning here. Now it's a just argument. So you see 0.5 gives us a bit of different range of neighbors. And then I use, again, the gradient here to map the darkest color to the darkest point. And if you look closely, and that's why I have so small dots here, is that we still have individual points. So you get kind of like an effect of points of different colors overlapping each other. So it's not really a smooth gradient. Each point is colored by a number of neighbors. And obviously this one now you can't group by any further color aesthetic because this is now blocked for this variable. A pretty fun package. I haven't used that much yet, just for the USGS map so far and a bit of playground tests. It's the ggplot package. I'm still exploring it. The idea is the same. We have overlapping points, but now for 2 different or more groups. And the problem is if you have multiple groups, then you end up with like these, it depends on which in which order these points are plotted, right? If you have a lot of points, then maybe the orange points are on top, or otherwise the purple points are on top, and you can hardly see if there are some underlying plots of the other groups. And the ggplot package tries to approach that. It has quite some interesting syntax. There are even 3 different ways how you can write the code. So I will showcase it here. It's a direct stolen mostly from the vignette. So feel free to read more about it. So the first one is this piping thing. And we pipe the geom inside our ggplot code. We pipe it into the ggplot package in the blend function. And then there's a multiplier option here, for example, which creates this plot where we basically mix the colors where there's overlap. You see that these points become very dark, and it looks a bit wrong to us. From a color theory, it seems to be that the blending is perfect, but also, again, Matthew K's package, he's discussing that, and you can go further and combine multiple blends here to make fine-tune this experience here. So I'm calling now the package because I need multiple functions from it. And then we have this partition variable. And again, I'm not going into detail of the technical parts here, but we say basically the color should be partitioned by day and night, so our two groups. And then we now have a different syntax here, not piping, but these arithmetic operators. So we multiply a light and blend, and then we add this multiplier with a given alpha. Again, don't ask me on the details. I'm still kind of like figuring out how really to make this accurate. But you see now the color looks more natural to us as a mixing of purple and orange. You can even combine this with other GMs, then the code becomes even more complex. Now we have a list of two GMs. One is the first one as before, the GM points, which we blend in the first step. And then we add these, in this example, this vertical line indicating the mean of the humidity range. And this list now we pipe into another blend function with another setting. It's called hard.light. And then you see that we get a mixture of the line and the points which are actually below the line. So usually you won't see them. Still exploring options for this for a use case. If you have one, feel free to share it with us, or once you have done it, to tag me in the post or whatever. Curious to see what people are doing with this fancy functionality. And the final one for this part of XY relationships is the ggDensity package. It's a simple package to create density curves. And you might now wonder, well, we can draw density curves already with ggplot2. I think this has a bit of a nicer experience. I will also, at the end of this package description, give you a point why the author thinks this is a better way to create densities. So from the ggDensity package, there's a gm_hdr_lines layer, which creates these different shades of different probabilities of the two groups. This is a bit messy here, so let's move on to another example where we can maybe see a nicer split of the two groups. It's actually using a KDE estimator to calculate these areas. And here we see we can nicely separate these two groups and highlight the densities of the points. You can also change the methods. There's, for example, these normalized multivariate normalized functions. I think you can also specify your own method. You can also fine-tune the probabilities. So here I now have a vector of probabilities. Note that it needs to be in descending order. Otherwise, the legend breaks. I reported this today as an issue. So here we have now 95, 75, 50%, 25%, and 10% ranges. And it nicely creates these ellipses around your data. There's other HDR functions, for example, the HDR points GM, where you can color the points. It's kind of similar to the GM density. No, not the GM density, the other one, the point density package, the GG point density package. But it basically colors the groups as categories for your given probabilities here, and with black being the inner group of the 10%, and then purple being 50%, and so on. And the use case or the motivation to create this package is that the GM density functions, there are multiple of them in ggplot2. They create nice looking density contours. But the legend, if you look at the legend, this is not really that meaningful. And also how they estimate it, it's based on equal size steps. So the GM-HDR, as mentioned, uses proper statistical methods to calculate these ranges. And thus also the shape is a bit different here. And also the legend becomes more meaningful. And on top, it has these points. And also there are some other HDR functions for lines and so on to create different chart types. Okay. The second last section will be working with text. So we update the theme to have the legend on the top, just to have more space, because I'm now shifting my setup to a column-wise setup. We have a bit of more code now in the other examples here. I'm now using the monthly data set we have created in the very beginning. Here you now see the nice labels I created with the lupridate package with the label option. And they are already ordered, so it's not alphabetical. These are ordered factors. And I create this simple line chart of the number of counts, so the bike shares per month in the year 2016 for these two periods. Nothing spectacular. We add a GM line with a certain line width, and then again, the manual colors. And one of my recent findings of exciting extension packages is the GM text path. And I think this is really wonderful because it saves so much work on labeling line charts. And it's pretty straightforward. It says a GM text line, and certain multiple other GMs are also there, like GM text area and others, which we can add to draw both the line and the label at some point. So note that the GM line now is removed, so it draws both. And we then pass a label as usually in a GM text. But if you know ggplot a bit, then you know that if you would just pass a GM text here, it would draw 24 labels, 12 night labels, 12 day labels for each of the months. So this doesn't look nice. It was also overlap with your line, so you would need to adjust it. If the lines are closer to each other, you end up with overlapping labels, all kind of stuff. So usually the approach is to generate either statistical transformation to just draw one of the labels, or to create another data set you pass then. And this is all something you don't need to do with this great package here. With this functionality, it adds, this is the default setting, it adds the label in the middle of the line, so horizontally. And then it also vertically places it in the middle with this nice fancy gap of the line where the label is sitting. You can then further streamline this. So the line width argument applies to the line as before, a bit thicker line. And then we can fine tune the fonts and the sizes and so on, the styling of the label itself. If you don't like this line break, for example, or you don't like the position, and it depends a lot on the data, obviously. If we would draw the day label exactly at the May measurement, then we would end up with a very ugly label. So you can also fine tune that. Of course, we can remove the legend now because that's the good thing from a database perspective, right? We directly annotate our lines instead of having another legend, which lets people flip around between the encoding and the actual data. So to showcase that this also kind of works, oh, I forgot to remove the text smoothing. I was working around with the text smoothing feature, but things got worse. So if you remove that, and I think in the script it's not in there, I will update the slides accordingly. Then you have nicely formatted labels here, not so much overlapping here, but I'm passing the bikes monthly data set just to overwrite the labels to showcase a bit longer labels here. And you see it follows the curve based on the data points. And then I just pass that and I move the label a bit above the line so we don't have this line break. This is the vertical justification. And the horizontal justification then defines if it's placed on the left, the middle, or the right. So I'm moving it to the very left with 0.5. So not at the very sharp end, but here to the left. And then the text smoothing you can use to fine tune how much the text is curved. As you see, sometimes looks better, sometimes not. It looks a bit better if we make this a white figure here. And again, if you remove the text smoothing, this AM should look a lot better by default. The next one is ggforce. And the ggforce package is a magical package with all kinds of things, mostly GM layers and stat layers, but also facet stuff and all kinds of things. So it's a nice box of tools, and I always love to go to through the documentation and have a look what else is in there. Georgios used it to draw penguins, actually. Nothing you have to do, but if you enjoy that, that's definitely something fun. I want to highlight something else. We are still in the working with text section, and I really love the available functions to add annotations to your plot with ggforce. First, I'm going to store this simple scatter plot of a temperature count versus temperature in an object called G to focus on the actual added functionality by ggforce and not repeat this code again and again. So I store this inside this G object, and every time now I can extend that with other components. And here I'm using now the gm_mark_rect. There's a family of these markers in the ggforce package where we can pass a label and then also directly can filter our data. So basically decide on which group we want to highlight. So you could use it to, I have brought an example here. You could use directly label your day and night groups here, putting boxes around it. Here I used it to highlight these two outliers, which were due to network strikes in London in 2015. So I filter the count to be above 40,000, which gives me then only keeps those 2 points. You see it's also colored because these are day observations, and the box is still colored in orange because we passed it as a global aesthetic in our G-object. So again, we can fine tune this. Now I turn this into, I override the color mapping by just setting it to black. So we have a nice box around it. I use my typeface here, which I use for the plots, and I increase the label size. And then what's really exciting, so some people love this, this kind of annotation with the distance, with the gap between the box. Some others don't like it that much. You can fine tune all of this. I think it's quite some modern fancy annotation, which comes out of the box. So usually it's the other way around. You have to fine tune it to make it fancy. If you don't like it, you can definitely modify it as you like. But what I really love about it is the option to add a description to it, which directly has this different formatting of bold versus non-bold and different sizes. I even fine-tune the sizes here with the label font size. Now I pass a vector. The first one is the label, and the second one is the description. And you can do this also for multiple groups. Here I'm showcasing this for one. You could also obviously have a list of descriptions and pass that as an aesthetic, I think. And then as mentioned, this is a family. So this was the rectangle. You could also turn it into a circle. A note on where it's placing the this annotation line and the label itself. There's not really a control of that. So depending on the plot size, you might end up with a nice looking label or not so nice looking label. It can't see the points, for example, right? It's a new layer. So it will sometimes maybe overplot your actual gems, which are underlaying, for example. Yeah, with the circle, you see it's placing it somewhere else. You can also have a hull. A hull here, it's a bit boring. It's still a rectangle, but but you see it's rotated. The other one will always be aligned with the horizontal and vertical axis. If you have more data points, then it draws kind of like polygons around your points. And then, as mentioned, you can fine-tune also and remove the gap. Not going into the details here. There are tons of more technical arguments where you can fine-tune the length and the behavior and so on of these lines, gaps, and so on. One of the examples, I've used that for a client. Sorry, it's in German, but it's not about the content here. This was a survey, and instead of having a legend or writing it somewhere else on the top, we have these direct labels here to indicate the different colors, which, as you can see here, modified ggforce geomarkdown methods. And then finally, the ggtext package. I hope you know that already. It's a package to render text. So in the basic ggplot2 package, you can format your text. You can turn it into bold or italic or bold and italic, but always for the whole element. So you can't really modify single words or groups. And I'm a trained biologist, and Klaus, who has developed this package, he's also working in biology. And there, for example, we want our Latin species names to be italic, but not all of them. So if you have a species name in a subtitle or a callout box or on the axis, you always had to turn all of the letters into italics, which is not the idea of turning your Latin species names into italics. This was the motivation, and we can use Markdown syntax for that. I guess you know that from R Markdown, which became very popular among our users now. Also in Quarto, you use Markdown. In your GitHub README, for example, maybe even WhatsApp came up with a strange alternative way how to specify it, but follows the same logic. 2 symbols means bold, 1 symbol means italic, 3 symbols means bold and italic. Could be either these asterisks or these underscores, for example, depending on the setup. And you see now that I passed this in the GG title and it's not rendered. And this is not working because we still have to specify to load the package and specify that it needs to be rendered. So here we need to address the theme element, the according one. So I'm addressing the block title, and then I'm passing a new element. Instead of element text, I'm now using the element underscore markdown, which is part of the ggtext package. And now you see the title became bold. This is something I could also just pass as a general setting because all the title is bold now, but I don't have to. I can also do it this way. And you see period now is in italics. Not a species name here because, yeah, bike data. Sorry for that. You can also pass, oh, there's a question first, yes?
Just a curiosity. why would you choose to use ggtitle more than add a simple title and then ggtext element markdown in the theme function, or I don't know, like adding if you want to move the text on a different place, you can have other option. But what is the difference in why would you choose ggtitle instead of just using a lab function or adding?
Yeah, so this is usually if I teach, then I also always suggest to use the labs function, because I like to have all my labels in one place. Also, labs function gives you more control of also the subtitle and the tag, for example. Here in that case, I use the ggtitle because it's shorter in that sense. You still can't see all of it, but for otherwise I would go for labs title equals. So I usually have a labs function because I'm also overriding the axis labels, for example. In that particular example here, I'm not dealing with polishing all of the plots. So this is yeah, just a workshop situation. So very rarely I just use ggtitle. But yeah, you're totally right. The labs function would work as well. I usually also suggest that if you have more than one label which you want to customize. And if you want to move it inside the plot, I'm not going to show that, but there's also gems which have the same logic. So there's these elements for theme elements. If you have data related labels you want to place inside your panel, and there's also gems which are featured by ggtext. Yeah. Okay. And you can also use HTML, CSS specification of your text. So you can see you can do a lot more. I copy pasted the same code down here because it became a bit longer. If you're not familiar with that, this is how our web page looks look under the hood. Tanya showcased it yesterday. If you go on any web page and highlight something and hit your right mouse click or whatever, F12 to inspect the element, then you see basically the same or similar things where we have like tags, and here the opening arrowhead B closing one is basically bold. We also have EM or I for italics. And then we have the style argument where we can pass certain other features. Not all of them which are working on a web page are working in ggplot as well with ggtext, but quite several. So I just showcased here that you can change the font size and the font family of single words. And you can obviously also change the color, which is very exciting. And a lot of people, especially in the Tidy Tuesday world, are using to remove legends and have these newsroom style of highlighting the different groups in the title or subtitle. The element is still called element underscore markdown. Every time I teach this and talk about it, I say like, yeah, I actually would have liked to have a different name here, but this is what they decided on, the package developers. So it's obviously not markdown anymore, but the same function, the same element is rendering also HTML, CSS specifications. Okay, and again, we can remove the legend now because the legend now is now a title. And as mentioned, I've used this for several client projects, but also Tidy Tuesday and other challenge contributions. So this is just one example where I highlight these both colors in the under subtitle here to kind of like make sense of these two different radial bar charts here. I've used it to the geoms here to add these annotations on the X-Men stream graphs I've created on how often the main characters are depicted and talking and so on in these comics. I also have used it to build this legend here on the left and the text. So this is also 100% ggplot, not necessarily something I recommend to do, but definitely something you do if you're participating in Tidy Tuesday, because you want to make it 100% code. So this is basically another plot where I have like different text boxes, but then also point size. So this is the actual value you see on the other side. Lots of additional text labels, and these are also ggtext gems where I use different styling of the labels and different colors and so on. And also here you see bold text inside the descriptions. I also used it here for these friends visualization, this fun visualization of mentions of different partners in the dialogues of the TV sitcom Friends. And here the axis labels are colored according to the main character. And I'm not going into detail how you do this. This is more like a data wrangling step, but if you want to do this in an efficient way, you will find in the appendix an example how you would create such a graphic. by not just typing each of the labels by hand, but combining them with mutate. Okay, and then as the last example from the ggtext, and the text section here is handling long titles. Here now I have a very long title, and you may likely know that ggplot at some point is just cutting your title, or it's overfloating your actual area, and there's no line break or automatic line break included in ggplot2. You can add manual line breaks, but then every time you change the width of your plot or the size of your font and so on, you have to basically do this again and again by hand. And luckily, there's also an element underscore text box and an element underscore text box underscore simple element in ggtext, which does this for you. It has some issues with you get very long, then you have at some point also overlapping stuff because you then need to adjust the margins. But overall, it works very well, and especially if you automate things where you don't know what's the title length, for example, you could write some functions to do that, some logic, like basically count the numbers of letters. But if you don't have a monospaced font, you end up with different lengths. It's not only the number of letters and so on. So you can control that with these elements. And you then can also style it, as mentioned. You maybe want to adjust the margin, the line height, and then you can even go further. It's a box now, so you can also add fill and outline colors and do all kinds of things. You can also use this for, I don't know, I'm not sure if it's the element. I think you still have to fine tune it, but you can also use it for facets. For example, you find an example in my tutorial, the ggplot tutorial, and also somewhere is a Stack Overflow question where Klaus was answering that. And then you can also obviously combine it with HTML or Markdown highlighting. So here I've colored and italicized the day and night variables again. Okay, and the last part of the section, I think we're very well in time, it's a 1 hour talk, is interactive graphics. And as mentioned, this is a ggplot2 session, so usually it's all about statics, and I'm not really going a deep dive into all kinds of interactive graphics because most frameworks use JavaScript under the hood and use some JavaScript libraries. And if you now expect me to talk about Plotly because, well, this is ggplot, I just have to pass it to Plotly. Sorry for that. I'm not a Plotly fan. I like the simplicity and so on, but I actually always dislike that only certain elements were kept, and there's a lot of things I could not control the way I can control it in ggplot2. Obviously, you can also use a high charter, e-charts, grapher, all kinds of, if there's mapping, leaflet R, tmap, and so on, multiple frameworks. But if you want to code in ggplot and make use of all these tricks you have learned over the time, then you wish for either observable plot, kudos to Tanya, which follows also the grammar of graphics. But if you would truly want to write ggplot2 code, then there was kind of like a missing package, which is now filled by the ggiraf package, or ggiraf. We discussed last time how to pronounce that. I think it's a joke on giraffes. Not going into the code into all detail. It's one of the plots we have done before. It's the line plot of day and night counts. And I have highlighted here line 3 of the code where I pass the I need to get used to it because I usually say ggiraf, which is the common geom you know from ggplot2. There's also points and sf and so on. Here we're using the line, but you see that it has this suffix of interactive. And then we have new aesthetics, tooltip, and data ID to highlight what's going to be shown on the tooltip and how it basically groups the data. But it's a common geom, and I will showcase that it also works with other extensions in combination with the next example. And then I stored it in an object because it's still a static plot. If you would plot it, it would look totally the same as without the interactive part. And then I'm first setting or updating the defaults of all the plots created with ggiraf here. We have a toolbar and we have a zoom option. So it's the same things you can also do with Plotly. So often people respond like, yeah, well, Plotly comes with all these cool features. Well, e-charts, ggiraf, and all kind of other packages also have these functionalities of downloading your plot and stuff like that. And then we have to pass that into the giraffe function from the ggiraf package. And you have to be explicit about the GG object here. This is something which took me again and again. Every time I go back to it, I forget about it because I'm often implicit matching my arguments. That's a good reminder that sometimes a good idea to be explicit about it. So we pass this ggplot object with the interactive geom. Here I set the width and the height of my SVG so that it nicely fits my slides. And then we also can override some of the options with these gggraph options functions, where we then can pass some arguments and also some CSS code here. So here I say basically when I hover on something, line 15, the stroke should be increased to a value of 5. And inverse, so everything which is not hovered should become more transparent. And this is now the line graph in action. Likely not a plot you usually want to use interactivity on, right? We can use the GM text path label for package to label these, for example. But to showcase a simple thing here, you can nicely now interact with these. Rather silly example. So let's move on to a bit more advanced example. Well, actually not from the code, but also showcasing that you, again, can combine it with other packages, and which is a nice thing which would not work in Plotly likely. So here I'm creating the same plot as before, or a similar plot with a geomark hull to highlight the outliers, and also a GG text rendered title. So these are now extension packages, and I'm I haven't tried it, but I'm almost 100% sure that it will not work with Plotly. It will just drop or give you an error, I guess. Otherwise, prove me wrong, please. And I'm now using the GM point interactive instead of the GM line interactive. I'm passing as a tooltip and the data ID the date. And then again, I'm moving this into the graph function. And now I have a bit of other adjustments here. So again, the hover and hover inverse, it's a bit different here because it's a point now. So I also increase the stroke width and the size of the point. And then you can also style the tooltip. So here I say, please, the box around my tooltip should use the fill color. So the color we have mapped. And again, a bit of CSS to use the fonts I use in my visualizations to make it bold and so on and so on. So if you know a bit of CSS, HTML coding, you can really fine tune all of these kind of things. And yeah, this was something I was trying to do. So last time it worked. So you see that maybe I need to reload. I was 3 minutes before we started, I was trying to update this. Let me see if it worked. No, didn't work. Okay, bad showcase here now, but I definitely made it work. But there seems to be an issue from time to time with certain fonts, maybe. Strange because last time for the Berlin session, which is just 3 weeks ago, so it was still working. Nevertheless, you can use rendering here. And yeah, promise with certain other setups, this might work here, but we can highlight certain words. We also can use the ggforce annotation here. And now these points are interactive. So if I want to look at the outliers, which exact date these are, then I can hover over them. And because I have paired them by date, you always see the response, the other measurement on the same day, which is for the night data. And if I move around, you can basically explore pairs of data. Okay. Yes.
Yeah. In fact, I experienced lots of difficulties with this, like changing in, so adapting the output to the desktop, or if you are on a full screen or not, it shows differences. So
okay.
Yeah, even with the presentations, for example, not only with graphs. Okay, with graphs you might have other issue until you just save it as an image, and so that is framed. But with presentations, sometimes when you do like full screen, you might expect things different, so changing things, and I still didn't quite catch why those things happen.
Yeah, likely because it's a fixed size, and if you change the resolution, basically, then also with the Quarto, it's the same. Like if you're now looking on your mobile phone at the screen slides, then likely the footer is very huge. Usually, you have in the web dev process, you have kind of like basically evaluation of the size of the current screen, and then you adjust the labels or the text sizes accordingly. I'm not sure about gggraph if this is possible to have something like that. I honestly also never tried to use gggraph or look at this on a mobile, but good that you mentioned it, something I will definitely explore. So usually one solution to this is instead of fixing these values to pixels or point sizes for fonts, is working with something called EM or REM. Don't ask me what this means, but these are basically responsive units which rely on the size of the screen. But not sure if this fully works with gggraph in that context. And for Quarto, it's the same thing. You can have rules that on a certain screen, the sizes should change, for example. I think that should be absolutely doable. And for web pages, Quarto web pages, I think that's also the case somewhere under the hood that it's adjusting the sizes.
Yeah, and also I have another question.
Mm-hmm.
When you like render your plot on our studio, for example, and then so you have like a legend, and then you position the text, and it when you visualize, it depends if you use an R script or an R markdown or a Quarto 5, so things changes a bit. But you visualize your plot, it seems fine, but then you save it and things might change.
Yeah, that's a common issue. There's no workshop or seminar where not any someone is asking that question, or like, and I think we all in the room have been there basically. At least I remember that moment very well. I was fine tuning my visualization for 2 hours, or maybe even more, and then exporting it, and everything looked messed up. So the usual recommendation is to use, for Quarto, unfortunately, work for figure width and figure height. So if you use the old R Markdown chunk options, like with the sizings of inside the curly brackets with the figure width and figure height, and you have an inline output in your R Markdown or Quarto, the plot should respect that. And if you use the same numbers, if it's 7 and 5, for example, and you use inch as the default, if you use the same numbers for your ggSave command, then it should look exactly the same as in your RStudio. The other approach would be our camcorder package, which is another extension utility, which was originally, so it saves a copy of your ggplot every time you run a ggplot. And the idea was to create an animation. But as a side effect, we thought about, hey, we save in PNG anyway every time we run the ggplot. So why not showing the save PNG, which has a fixed DPI, width, height, and so on. And we show that in the viewer pane instead of the plot pane. So the plot pane is responsive and doesn't relate at all to any ggSave commands. But in that setup, you get what you see what you get, basically. Well, actually, the other way around, because we first save it and then we display it. So this saves you leaving RStudio, looking at your graph, going back to RStudio, which I have done 100, 1,000 times for every Tidy Tuesday, actually. Yeah. But that's something annoying. I've talked about this in both of the RStudio Conf and ggplot, the PositConf. You will find some slides on how to work with aspect ratios. So it's in the latest PositConf ggplot workshop. It's in the first session where I discussed this, also how to make fonts work, if you want to learn more about that. Yeah.
Okay, so I just unmuted all the participants because I like to allow them to ask you a question directly.
Sure.
If they want. It might be someone with the microphone on, because like Janina, we can hear you. So I don't know if you'd like to ask questions. But anyway, there is a question in the chat from Antonio Calvi. Yes. And it says, bar plots showing means and error bars are considered to be misleading when comparing groups. Hiding information about data distribution, for instance, what is a better alternative to them, in your opinion? Thank you.
Yeah, that's something we call dynamite plots or bar charts or bar graphs. There was an initiative. People were writing letters to editors of scientific journals to not accept publications with that. I wouldn't get that far, but I think it's definitely not the best representation, especially also for exploring the data. That's bad because you directly summarize your data. So when it's the explorative part, it's definitely good to draw jitter strips or something similar, B-swarm plots or whatever to visualize the raw data. If you have not thousands of observations, at some point this breaks, obviously. I've shown violent plots as an option, I mean, every summary plot is better than a bar chart with an error graph, error bar, because basically a box plot is showing the same information, but you can zoom in. You don't have to include the zero baseline, and you get even more details. If you don't want to go as complicated as a box plot, I showed you several ones in the ggdist, like the half eyes, the full eyes, dot plots, multi-interval strips. So I think there's a range of things you can use for that. Yeah. And to finish this up, sorry, wasn't fully done, but I don't have to talk much more, but just to let the participants know, here I have featured all of kind of other, some of them which I've covered and some other packages, sorted kind of what they do. So feel free to explore them because I wanted to highlight also the other packages, but I could, as you see, talk for hours if I would need to cover all of them. Also interactive charts, which are not all of them are ggplot2, but if you're now thinking about interactive stuff and you're not really convinced of gggraph or plotly, there are also other approaches to do that. So now I'm done and I'm open for any question.
Thank you. Thank you, Cédric. Is there anyone who would like to ask a question to Cédric directly, maybe? If you like, just unmute yourself and ask him anything, anything you like. Hello, Stephanie. Would you like to ask him yourself? Just unmute yourself.
I was just wondering if among those that you just listed, if you had any favorite other packages, since you were saying some others you're like, oh, you can do that. Yeah,
these are definitely my favorites. I put on the list. As mentioned, there's the official gallery, and then there's this long, awesome ggplot where you can go through. So my most used packages, I guess, are ggdist, ggtext, and patchwork, I would say. Likely I forgot one now. ggforce also is one of the highly recommended ones. But I also use sometimes very specific ones, right? Like a ggBswarm, which just creates bswarm plots, or ggsenke, which just creates senke charts. So they're also very, very tailored packages. And then if it comes to color packages, I definitely also have my favorite ones. So again, I'm a fan of packages which really work with the original idea of a grammar of graphics or a grammar of layered graphics of ggplot. So also these color packages, usually, most of them at least, come with a scale option. And I think Psycho, for example, is a wonderful for sequential and diverging ones. You know, maybe Arcato Color, which also has some nice, decent color sets. Yeah. But for geoms, I think most of them are listed here, which really provide new geometries and statistical layers.
Hi, I have a question.
Yeah, hi, Ronald.
Hi, thank you. Really love your work and talk.
Thanks.
Just had a question about AI tools, and are you using any specific tools? Do you know about specific tools that are more relevant for data visualization in R? And maybe you can elaborate about it a little bit.
Also, so the question was about AI tools in RStudio and R.
Yeah.
If I got it right, yeah. I'm not really, so I'm very limited to asking questions to ChatGPT for now when it comes to AI experiences, to be honest. I was looking into some, so there's this, I don't even know what it's called, but likely someone can post it in the chat. There is something where you can basically use ChatGPT and similar to create R code. I played around with it a bit about the ggplot, creating ggplots. It might be a good starter, but you need to know a lot of details for that because it's mixing all kinds of approaches, sometimes not working stuff, sometimes outdated stuff. It was often a mess. I heard about the new Copilot feature in RStudio. I'm not sure if it's already around, but if not, soon to come, that RStudio has a Copilot feature, which I find a bit more exciting to kind of like have more complex requests, which seems to work way better even with R. I know most people are using it for, at least from those I've spoken to, using it for Python. We're very impressed, but from the demos, at least, I think it's also very promising to R, but I also haven't used Copilot, to be honest, yet. I would think I'm faster than that, but likely I'm wrong.
All right, thank you.
Yeah, you're welcome. Grillo?
Giveaway, would you like to ask him yourself?
Hello, yeah, thank you very
Hi.
much for the talk. I was wondering, in the context of scientific publications, how would you like approach quote unquote creative graphs? Would you agree that there are like what you were talking about with the bar plot and the standard deviations? Like, do you think it's a good idea to get more creative to show that kind of data in a scientific paper, or what would you say is the best option?
Yeah, good question, and certainly not something which I can back up with data. As being a scientist myself, I think we have some choices which are just kind of like basically hard-coded, and we always did it like this, and then often the answer is also like the audience is used to see it like this, even if we know the drawbacks of the certain visualization. So I think it's always worth at least to explore other options. So instead of just going for the one single graphic, in any context, I think it's nice to explore different options. Instead of just saying like, well, I know how to use bars. I've always used bars, so I use bars every time. Just to see, so one thing is for the sake of variety when it comes to bars. Bar plots are, and also I'm doing a lot of bar charts, which is totally fine. The other thing is like really distributions, right? If I know I have a uniform distribution, there might be nothing wrong about a bar chart with an error bar. But if it's about paired measurements, for example, and there's a very nice paper from Tracy Weisgerber et al. From 2015 in PLOS Biology, which is called Beyond Bars and I don't even know what's the second one, lines, I think. Where they showcase why you likely also want to visualize the distribution, at least for the explorative part. And then if it comes to communication, there's a strong debate about, is it good to confront people with unusual things or not? With one team saying like, well, we need to do this. Otherwise, we can never establish new and better ways to show our data. And others arguing like, well, people are used to it, so why should we confuse them? It depends a bit on which of these ends you fall and your collaborators likely. I think the best idea is to really try several approaches to visualize the data and then ask people, does it work, doesn't it work? So for example, box plots are wonderful summaries. At the same time, I still think many people, even people who know how to read it and are aware of what they do and what they are meant for, they fall in the trap themselves by basically hiding some information. Sample sizes, right, distributions, focus on the center group and so on. So saying all of this, in context, yes, I think it's a good idea. I think you should not become too uncommon. If you become too uncommon, right, and really experimental, I think this is nothing which kind of like serves the paper very well. But if it's improving kind of like your story and the underlining your findings, then it's definitely worth it. And I think also like in terms of, because I was also in the review process certain times and where people were recommending wrong chart decisions to me, which obviously annoyed me a lot. I think it's also, you can be bold to your supervisors, the editor and the reviewers, and by saying like, well, see, these reasons why I use this chart approach. And then there's even scientific literature on like the Weisgerber one, but also many others, which you then can cite to say like, well, see, there's even a scientific publication supporting that B-swarm plots, for example, work better than these other charts or whatever. So yeah, I'm definitely on the end of, yes, trust people, they will figure out. And it's also you who's explaining these charts, either by talking about them or writing about them. So I think we should also expose people to new approaches.
Thank you very much. I
You're
really
welcome.
like your blog. I've been following you
Thanks.
for a long time now. So thank you.
Thanks. Thanks for joining.
Great. So we have a Grillo. Would you like to unmute yourself?
Oh, I think this was Grillo, right? Yeah.
Okay. There is one more question about, can you use the HTML tags to change the color of the text in titles if your output is a PDF, or would you have to pass the LaTeX code?
Yes. Yeah, hi Josh. You definitely can do that. So the HTML code is not active in the sense. So in the plot, there's no HTML code anymore, at least in the static one. If you go on with gggraph, then you have HTML code, and it seems it's not always properly translated. But if you save your ggplot as usual, or you have it in a, it sounds as you have it in a R Markdown Quarto setup, then it's rendered, which means just the final styling is saved, basically. So the HTML is used to render that, and then basically it's just pixels saving the italic, bold, colored text. So there's no HTML dependency anymore in your final plot.
Okay, one last question
Yep.
From Sophia. If you have an analysis based on repeated measurements, what are some of the better ways to show this data, as the samples are not independent?
Yeah, this is also something which is in the Weisgerber paper, actually, which is exactly what I always have used as an example why you should actually look at these measurements, especially if you have paired measurements. Is a slope chart, definitely. If you don't have too many points, so it's a bit of a question, but even if you have many points, I've created slope charts for all countries of the world. And then obviously it's a mess for some of them, but it depends again on your story. If you want to highlight those few which are going down, so let's say you have 200 patients or whatever, and then only 5 of them are having a negative trend, and you maybe want to highlight them and showcase. Well, it's not many, but here there are. And Tracy makes a good case in her paper why this is a useful thing, because depending on the slopes, you can directly get an idea or you see outliers or different group behaviors. So it could be a mess, things going up and down and being stable, but it could be that all of them are going up and only a few are going down. And then you will maybe go on and further investigate what is the difference between those two groups, for example. So slope charts, and even so something or parallel sets comparing multiple measurements, parallel sets or slope graphs, I think. Dumbbell charts are also wonderful, which is basically a slope chart on a single axis.
Okay, so I think we are, so our time is up. Thank you very much, Cédric. So that was amazing. And so we look forward to more of these events.
Yeah, thanks for having me. And yeah, feel free to reach out if you have further questions we couldn't answer. And yeah, see you around somewhere on any of these many social media platforms or wherever you're still hanging around. Have a nice evening.
Thank you.